Building a game engine is a huge software project. We've talked about this before on Developer Voices. If you want to build a game engine, you are going to need some kind of game business logic library. You probably need a networking stack. You certainly need a rendering engine with animation support, collision detection libraries, a GUI library, maybe a whole new scripting language, probably a whole IDE and more. It's a colossal thing to build a game engine. And as you're going to hear me say in this discussion you're about to hear, if you gave me a team of 100 programmers and 5 years to do it in, I couldn't guarantee that we'd build a successful game engine. So what hope could one person have? I'm joined this week by Dmitry Stepanov, and he's been working on the Fyrox game engine almost solo for almost 5 years. And it's incredible how much he's built of something the world is crying out for, a viable game engine in Rust. He's got good form on it. He's been building games for years. He's built a game engine in C in the past. He worked at Larian Studios on tools for the likes of Baldur's Gate 3. He knows what he's doing. If anyone can build a game engine, he can. But can any one developer build it? This is what I had to find out. I got him in to talk about what it takes to build a new game engine in Rust. And along the way, I learned some really surprising things, like how do you do hot reloading of Rust code? Doesn't sound like it's possible. How do you do runtime reflection in a language that doesn't really support reflection? And what are the hard parts of building a game engine? The answer to that is not what I thought it was. So let's get into the questions. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Dmitry Stepanov. Joining me today is Dmitry Stepanov. Dmitry, how are you?
Hi, I'm fine. And you?
Good. Yeah, I'm glad you could join us. I'm very well. I'm glad you could join us because you seem like one of the busiest independent programmers I know. So thank you for carving out an hour. You have been, if I think about large programming projects, writing a programming language and getting it to production is huge. Writing an operating system may be larger. The only thing I can think of that's actually larger than all of that you have been trying to do solo, which is making a game engine.
Yeah, that's tough.
So, maybe the first question is why? Why embark on such a huge journey?
Because it's my passion. It's what I love to do. Games is my passion since I was like a small guy, and I always wanted to make my own games. And from some point in my life, I decided to build my own game. I was like, when I was like 12, maybe.
Yeah,
it's quite a long time ago, and and yeah, it was very interesting. I was starting with Visual Basic and some stuff like those cartoons where you draw pictures one by one and animating it in a simple way, like if using a timer, like old style cartoons. And yeah, then I decided to learn about C++ and graphics libraries such as OpenGL, DirectX, and I was like, it just was so interesting, and I spent all my free time on this, and like I was like, you can like give me food, warm place, PC, and I will be here forever.
Yeah,
doing this. That's what I love. And but when I was in university, I started to build my own game engine and a game, and like 4 years after this, I released it in Steam. And
really?
Yeah,
what's it called?
It's called The Mine. It's like a horror game that was popular back in the day, and it uses custom game engine built in C++ and DirectX 9. it was already quite old at that point, because there was like DirectX 11, if I'm not mistaken. But it allowed me to gain so much experience with it. It's like building everything from scratch allows you to understand very fundamental parts of game development, and even how PC works. Because when you like writing in other languages or using high-level libraries, like Unity existed in that time, but I decided to build my own engine, and yeah, it would totally worth it. So it allowed me to become who I am right now.
But the thing is, like, most people get the surface understanding by using a library. If you go in and write your own engine, you definitely get a deeper understanding, but it's rare that you actually get to release. Because you go so far down the rabbit hole, right?
Yes, that's the hard part. It's hard to release with everything, because again, on my first game, it was so hard to release. It's like that law where you have to put 80% of time to the 20% of work or something, like it's called. I can't remember how it's called.
Yeah, I remember someone saying that you spend 80% of your time on the first 80%, and then the other 80% on the next 20.
Something like this. Yes, exactly. And it was so hard, but when you release at least one project, it becomes easier to do it until the end. But with game engines, it's much bigger task. It's mostly endless, because there is like a wide range of topics there. You can start from graphics, which itself is huge.
Yeah,
and it continues to guys continues to invent new techniques for rendering, and it alone could take like an enormous amount of time. That's why I'm trying to not focus too much on graphics.
Now we need to get into that, but what makes me curious before we dive into Fyrox properly is, from making your own game engine, you then went into the gaming industry, right?
Yes.
Did you work on the engine there, or did you work on games being used?
At my workplace at Larian Studios, I worked mostly on tools, and tying those tools with the engine. That was a wide range of tools. The entire editor, you could try it yourself. They released their Glasses editor. It's called Glasses, like these ones. And it's it's somewhat close to a mix of Unity, Unreal Engine, and specific parts for games, for their games. And I was working on animation, reworking other editors for Neurotech, some sound related tasks, and so on and so forth. Game development is like, when you dive into it, it's like an overwhelming amount of tasks that you can do. And no matter if you're like hired to work as a tools programmer, you you might end up working on sound, which isn't tool related, but yeah, I worked on sound, on animations, on crazy amount of different kind of tasks, optimizations, and so on. So, and also you can learn from existing game engines. So it's a good source of learning material.
Yeah, so this is the thing, right? There you are, gaining experience in different parts of a game engine. And it must have taught you a heck of a lot for what came next. But did it not also teach you that it takes entire departments to make individual parts of this system?
Yeah, that's true. That's true. There's like was 10 or so people working on graphics alone. Like five or 7 people working on the core functionality, and now I'm alone trying to do the same by myself. That's insane.
What was it? Was it like you had an idea that would make it possible for one person, or is it just the itch that you must go and make a game engine regardless?
It's probably the latter because I can't like sit and like watch how other devs doing something interesting, and I also want to do this. And this game engine development is an infinite source of interesting tasks. So why not?
Okay,
We
fair enough.
just do this and enjoy it. And if you one day like look back, and you will be surprised how much work have you done, and it's insane sometimes.
Yeah. What's that thing like when you're climbing a mountain? Never look up towards the top. Just focus on the bit of the rock you're on.
Yeah, exactly.
Yeah.
And what I like about game development and engine development is that it's like an infinite path which you can enjoy. It's not that particular small task which you finished and what's next. It's like it's like about the path, not the goal.
Right. Yeah. I can see that. There's always plenty more path to keep walking on.
Yeah, exactly.
So, well, in that case, let's start the starting point, because the first thing that jumps out about Fyrox as an engine is that you chose Rust.
Yeah, I never regret it.
Never regret it. Okay,
Yeah.
so why choose Rust in the first place, and why has it worked out?
At first, a bit of some tiny amount of history. I started Fyrox in C, actually. So back in the day, you can actually find it on my GitHub. It has a silly name of Dmitry's engine, like it's
Dmitry's engine. Because that's no worse than Gary's mod, which I gather is
yeah, exactly. And I spent so much time trying to fix quite annoying bugs like memory corruptions, because this language it's very powerful, it's cool, and it's simple about C, and but it's so uncontrollable. How can I call it? Everything could easily go out of hand, and you could spend like hours, like days, weeks debugging stuff, simply because this language is so it doesn't control anything. While Rust, on the other hand, is a life changer, because it controls over like invalid use of memory, like where you have something borrowed for a mutation, you can't do another borrow for mutation. That prevents like that famous problem with in C++ where an iterator becomes invalid because the memory was like moved somewhere else, and pointers in that iterator and pointing somewhere. If you're trying to read, you will get memory corruption or something like that. Not read, excuse me. Right, and yeah.
Yeah, I sometimes wonder if you have to, in order to really love like the borrow checker, you have to experience like being absolutely sick of memory being unmanaged.
Yes, that's true. Actually, it wasn't so easy to transition to C because
To Rust, you mean?
From C. Yeah, exactly.
Yeah.
Sorry. Yeah, because those paradigms used in C or C++, they're so like heavily embedded in the mind, so you can't easily let them like release them. And
yeah, it's like how to solve a problem in C, but you don't get. So now you're in Rust, you don't know how to solve that problem habitually.
Yes, exactly. Like in C or C++, you would just like have a row pointer or smart pointer in C++ specifically, and while in Rust you can also do this, but then borrow checker kicks in and like says, no, you can do this because you will get this, that, and this, but you can always silence it with unsafe. But why at all switch to Rust if you want to use unsafe? That's insane. So yeah, just accept the rules of the language, and it will be fine. It took me 3 months to realize that. It was hard, really. I stopped and then started over, and I like pushed again and again, and finally come up with solutions that allow me to write it almost like fluently. And from some point in time, I was like looking back at C, and I used it daily on my job, and it was so annoying after I get used to Rust. That's insane, actually.
Yeah. I sometimes think the mark of a good language is you find it hard to go back.
Exactly.
You often don't know the real advantage of a programming language until you start to miss it.
Yeah, that's true.
Yeah. Okay, so where do you start? I mean, assuming you're in the past getting to grips with Rust, settling on that as a choice, I don't even know where you start with writing a game engine.
Uh, it's it's quite common that you like output in a cube, like a rotating cube.
Start with a rotating cube. Okay.
Yeah, exactly.
Yeah.
That's what most guys are doing. Is like starting like with rotating cube, and then starting to like extend the functionality. But I cheated a bit because I had a C game engine that had a scene management system, a resource management system, like basic UI, a sound system, and I just ported it.
Oh.
So
Right.
my but uh, that C engine wasn't very like capable. It was very basic, and that constant fighting with random bugs because of memory corruption, that was quite annoying. And I decided to like port it the first, and then it was. Uh, it was a good starting point to like add functionality. I if I remember correctly, what I was started doing after the switch to Rust, I started implementing animation system that can allow to like not only play animation and switch between them instantly, like creating this weird jump effect, but to do smooth blending. So I spent some time designing the animation blending system, and that was
Am I right
very
in thinking
interesting.
that's the thing where a character is swinging a sword and then you press jump halfway through the swing, and instead of glitching across to the jump animation, it smoothly goes into a jump from
Yes,
a swing?
exactly.
Yeah.
Yes, exactly.
Okay.
It's exactly what it's doing. It's like blending two animations. It's like creating a smooth transition between them.
Yeah. The way actual humans move.
Yeah.
Yeah.
Uh,
I've got to ask, when you said you ported the C, did you just like have the C in one window and write some Rust, or did you FFI into the C and gradually eat it away?
I rewrote it from scratch, basically.
Okay, right.
It was much easier because this FFI is itself quite bug prone, and you can basically steal offloading work to C and creating like a safe wrapper in Rust, but it wasn't worth it because Rust itself, it's like the same. It's as fast as C and much more reliable. And why would you do this? Why would you? Why would you like create an FFI? In some tasks where you have a very large library that does specific task, very good and tested throughout the years, and that's totally worth to doing bindings and use it. But in this field where I'm experimenting a lot with game engine, it's like easier to rewrite everything. Something like this.
Yeah, that makes sense. So let me see if I can get the how this engine works. Is there? I'm thinking of Bevy. We recently did an episode on Bevy, and that seems to crystallize around this idea of ECS. Is there
Mhm.
kind of an overarching organization within Fyrox that I can get my head around?
I'm using somewhat classic OOP approach,
Okay.
but it's classic in not in like this weird way, which is in everyone's mind, like where you have this weird inheritance trees with the diamond inheritance and so on and so forth.
Yeah.
It is more like I don't know how to describe it. Maybe the classic approach which was invented by Alan Kay, sorry, and where you have like objects uh, and like you use message passing to communicate between objects. But again, that's not the full approach I'm using, because it's always good to find a balance between like I don't know if this is balance or not. I mean, um, in ECS, you have like tightly packed data and process everything using queries, like doing like batched work and so on. And you basically split your object into components which align into their own containers for better cache locality and so on.
Right.
While I'm using almost the same, but while keeping the object-oriented approach, where you have object and methods, and sometimes uses message passing to interact between objects. So again, in Fyrox, objects are all packed in the contiguous memory for better cache locality, but they are not split in those like tiny pieces that allows you to like iterate fast, and but it doesn't mean that Fyrox is slow, um, uh, simply because um, I'm using mixed approaches, which are better for particular task. So it's like a simple rule: use the like the Google, how to call it? Use the correct tool to do the job, like this.
So
Because yeah.
is it so I'm trying to think, because if you're doing a mostly OO based approach, Rust isn't an object oriented language. So are you bolting an OO mechanism on top of Rust, or what are you doing?
Rust is actually an object-oriented approach because it has traits and trait objects. It
Oh,
allows you to
okay. So you're
do.
just doing it through the trait system.
Yes, exactly.
Oh, okay. Yeah.
Yeah. So it's like a heterogeneous container that has these tightly packed trait objects and allows to like do dynamic dispatch that like allows you to call methods of particular type, like standard approach. I mean,
Okay.
in
So you have like a health trait on certain characters and enemies in the game, something like that. Is that how it
Not
breaks down?
really,
Oh, okay.
because building block in the engine for scene objects, I mean, is a node,
Okay.
scene node, and that node, the node itself is also a trait object, so can be, so it can it has an interface that can be. Um, Implemented by some specific node types, and also to be able to extend the functionality of scene nodes, there is also a scripting system which allows you to attach as many scripts to scene nodes as you want. So
Okay.
nodes themselves, they are doing some specific work to be in a fast manner. Like since they're scene graph nodes, they like contain local and global transformation, visibility flags, enabled or disabled flags, some specific parts like name tag, and another common parts like how it's called, the links to resources from which the scene nodes were created for a property inheritance system to create a nested prefabs. So basically, it's like like this tiny building block which you can extend. You can either create a custom scene node that will extend this functionality using composition. Basically, you have this like basic scene node. You like define it as a field in your own scene node and allowing the engine to access it so it can manage this part how it like, and other parts are up to the particular scene node type. But this is not so flexible. That's why the engine offers a scripting system that allows to attach custom data and methods to operate on that data, and yeah, something like this.
Okay, so let me see if I can get this. I'm gonna keep on the health example. So presumably I create a scene node which is the world, and in that I'll create a node which is a camera, and a node which is some lighting, and a node which is my player's character.
Yeah, exactly.
Right. And a spinning cube, of course, because you need the spinning cube. How do I then say, okay, that character has a measure of health?
That's quite easy. You can just add a field, like field called health, and to be able to interact with it, you have like basically two approaches. You can directly access the desired scene nodes from other scene nodes, like direct link, and it is very fast because you like directly write in or read in memory using some. It's still indirect access because it uses in indexes to not pointers, indexes like. And it's also not indexes, it's handles of generational arenas, if you know what it means. I can
handles of generational arenas.
Yes, yes.
You got to unpack that one for me.
So yeah, let me finish with the health example, and I will continue on those generational arenas.
Okay.
And and the second approach is to use messages. Like you can, the engine offers message dispatch system where you can subscribe a node to particular message type, and then other nodes can send this message, and it could be sent in different manners. Like you can send directly to a node and it will be dispatched to it, and it will receive the message in the same frame and process it, or it can be sent globally, so all the subscribers will receive that message, or it can be sent in a hierarchical way. So, and it also has its own flavors, because you can bubble message up on the scene graph, like you start from a certain node in some hierarchy, and you send in the message to itself, and it starts bubbling up to the root of the graph, and all the nodes on that path will receive this message. And also there's also another routing system that allows to deliver message down, so all children nodes descendant nodes will receive this message. And this is actually very handy sometimes, because like a recent example with this health related stuff, I recently redesigned damage system in my game, and I added hitboxes to enemies, like all parts of bodies like have their own hitboxes which moves together with limbs. And
so if you hit this part of the area with a sword, that counts as hitting the monster.
Yes,
Yeah.
yes, exactly. And since these hitboxes are actually inside the hierarchy of objects, and you can use this bubbling strategy to deliver messages. So the root actually is the like the character itself, and it has those children nodes. And when the message is like bubbling up, it will eventually reach the character, and we like it will react to this message.
Okay.
And
So I could have a bullet that hits the armor, and I send the 5 damage message to the armor, which then gets bubbled up to the character that can actually
yes,
deal with the 5 damage message. Yeah.
yes, exactly. Yeah, and it is
Okay.
super fast because you don't need to process the entire graph. You can have a graph of millions, like millions sync nodes, and you don't need to process all those sync nodes. You know exactly where to send it, and it will bubble up to the specific one. And sometimes you need to like sync to the bottom strategy. I don't know how to call it, where the message comes to all the descendant nodes, and this could be useful in some other scenarios, but I haven't like used it in any place, so it could be useful in some place.
I think probably the name for that is visitor, but we need something that sounds like the opposite of bubbling up. Bubbling
Yeah.
down doesn't work, but yeah, it's the visitor pattern, right?
Yes, yes. So that's for communication between scene nodes. So it depends on the how fast or maybe not fast. Like the first approach where you directly reference in an object, it is very fast because like direct access to memory. This one is a bit slower, but it allows to do this complex logic where you basically decouple hitboxes from character. It could be like explosive barrel, for example. You add the hitbox to explosive barrel, and it is not character, it is something different. And explosive barrel, like it listens to these messages, and it like if it's damage message, it's like decreasing the health, and at some point it explodes, and it just works, and it's like an awesome part of this message passing system.
So as a user, is this how I would do it? Like I would create a hitbox component, and then I attach it to certain things, and some of those can take damage messages and some of them can't.
Yes, exactly.
Right? Some parents can and some parents can't, but the hitbox component doesn't care. It just passes it up.
Yes, yes.
Right. So my next question then is, how do I write a component? Am I writing that by extending a node? No, I'm not extending a node in Rust because it's not like classical inheritance. How do I do it?
It's a script, basically. A script is like a piece of data with methods that will be called by the engine, and scripts can be attached to sim nodes, and they do all like business logic that you like. You can also like create custom sim node, but it's like very low level stuff and not so useful, except maybe if you need to do some rendering, like specific rendering stuff, then it might be useful. But on other stuff, probably yes, you will use like a script and attach it. Basically, every script, it's like a simple. Yes, it's like a simple trait object. It's directly it's located from random place in memory, so it might be slow, but in reality, like only a handful of objects have scripts. So if you like have 10% of objects that have scripts, it doesn't matter really. If you have 10,000 of nodes, and it still will be fast.
Yeah.
Especially if you design this system properly. By this I mean you can you don't need to call all the methods of this trait to be able to operate with this object, because some objects like have empty implementation of some method, and for this specific like optimization technique, Fyrox uses I don't know how it's called in like in academia or something like this. Basically, it has like a set of switches that allows you to tell the engine which method it should call or which not, and basically you can disable an update. So the engine won't spend time updating your script logic, and it will be fast because every such object will be registered in its own list. Like there will be a list of scripts that needs update, scripts that needs to be initialized, like specific logic, and this allows to fine tune this without harming the performance. Where in like I think in Unity, which has similar system, it does not have this ability. So if you look at the game object class there, you'll be surprised how many methods it has, and all of these methods will be called at some place. Like there are specific methods for collision detection, specific methods for update, post update, initialization, so on and so forth. And these indeed will harm the performance if you like have thousands of like tens of thousands or even more objects.
So it's like you've got some. I'm thinking of a simple example. If something's off camera, you mark it as being off camera, and then some kind of dispatch table says, "Don't bother doing camera stuff to that object."
Yes, you can disable animations for for objects that are out of frame, and you basically like do this load balance, and it works like it works very good because you really don't need to do this like super fast approaches. You just need to think about the problem, and it is good when you have fast approach. Yes, but you can really do in other way, like this one, like throw away those methods that don't need to be called, and that solves some problems away.
It's funny how, in some ways, writing games is a very different kind of programming to what I'm used to, and yet somehow some parts are very familiar. Let me ask you. So, this is a side alley, but I want to go down it. Is how do you measure performance? Is there a good set of performance measurement tools you're using to figure out where time's being lost?
Usually, I don't do benchmarks because that's like waste of time, really. Because I don't have this production ready parts that needs to be benchmarked. Right, so some parts of the engine they are production ready and they are well tested and like works quite fast, and that was proven by like me using the engine in my own games, because I usually find hotspots in the code by like do some gameplay tests, and like opening the profiler and see what's hot path is and fixing it. So since I'm mostly alone, but more to this later, because there are some very good people who started working on the project in the past like 6 months or maybe more. Yes, so the team is actually bigger now.
Okay.
So I can't tell that I did everything alone. There is a lot of people like doing small contributions, and tiny portion of those people doing like huge chunks of work, and that's very cool.
Okay,
So
we've got to get into that, but in that case, I'm going to pull back and say we talked a bit about scripting languages.
Yeah.
Tell me about scripting, because how does that is the scripting language Rust?
Yes, scripting language is Rust, and it's also using hot reloading. So basically, it turns the Rust in scripting language, because you can like push the button, compile the module, and it will automatically taken up by the game and the editor, and the new logic will like start spinning. And
how's that working? Because I don't think of Rust as in any way a scripting language. Are you? I can think of a few techniques that might work. What's your actual technique for hot reloading Rust?
It's quite simple and uses very well-known data techniques like dynamic libraries from operating systems. Pretty much any operating system allows you to load and unload code into a process. And the only problem that you need to solve is to how somehow manage the data between those loads and unloads. But that's solved by a simple serialization, because every object used by a scripting system requires to be serializable. And so basically, when you change the game code and click build, it will build a separate library. Then the engine will spot it. It will create a copy of this library of new version. Then it will find all entities from this plugin that you've rebuilt and serialize these objects, and it will be quite fine, grained, because it won't reload the entire scene. It will reload only specific portions, so it will be super fast. And like, for example, if you have a bunch of scripts from your plugin in some scene, and then do a hot reload, and then the engine will serialize those scripts, unload the library, and at this point, nothing from your plugin is attached to the engine itself, to the scene. And then it will load the new version and will create the new versions of the objects and try to deserialize their state. And basically that will attach them back to scene. It is simple, but Rust sometimes is weird in some, like it could create virtual pointer tables on demand, and those virtual pointer tables will be pointing to like weird places in your game. And if you created an engine object inside a plugin and then unload this, you will get crashed, because this vtable was created in the plugin, and it points to the process memory that is currently unloaded. And yeah.
Okay, so you can reload elements in the game, but you can't dynamically reload a whole plugin. Is that right?
You can reload the plugin itself, because it's also serializable. Everything is reloadable, actually, because but it creates additional problems when you do this, because, for example, I made a game, a network game, which connects those connections to server and like those non-serializable stuff, and having this strict constraint on that your object, like your plugin, needs to be fully serializable, and the serializable sometimes makes your life a bit harder, because so how you can serialize the server connection?
Yes, yeah. Do you have any notion of like those live resources that can't be serialized but must be recreated from scratch transparently? Or not yet?
Maybe you mean objects
Like,
that
I'm thinking like a TCP connection to the network server. You can't serialize that, but do you have some kind of life cycle? When you restart, this is how you will recreate it from the serialized IP address.
Yeah, basically it will try to reconnect and like do handshake stuff. Like,
do I just write that into my deserialized code myself?
Yes, unfortunately, yes. So you can, because it's native code, you have no other option, because it's basically you unload it from process memory and load it back, and you have like nothing left. Your objects playing data. I mean, without those fancy pointers and stuff. Like, I mean, just bytes. You can leave those in process memory because they're both of them using the same memory allocator. So the memory will be fine when you unload the plugin itself. So,
Right.
but for those objects that have those interconnections, this won't work.
Yeah, okay. So I'm just wondering how this plays out in practice. If I am writing a game, I'm testing it out, the character has jumped onto the first platform, I change the script that affects its jump height and just reload that. Does the rest of the scene stay where it is? Does the character stay where it is?
Yes, indeed, it will stay.
So I can independently change parts of a running game without restarting the level.
Exactly, and the good part is that it minimizes the risk of crash because of this. It's really like super unsafe stuff when you like unload parts of the process and reload it back.
Yeah.
Because the engine will try to minimize the changes. Like if it will see that some script changed, it will only affect that script. It won't reload everything else because it's just slow, and you want fast iterations. So,
out of curiosity, does it like freeze the game world while that's happening? If a bullet was coming towards me, will it pass through me while I'm reloading, or will it just freeze and wait for me to come back in?
It will freeze, reload, and the simulation will continue from the same point before reload. It's very it's very good for fast iterations, but sometimes it crashes because of subtle issues with those like memory management, like virtual table pointers, virtual pointer tables, and but it indeed saves heaps of time.
Okay, yeah, I can see that being like essential for fine tuning a game, which I gather is a huge part of the process of building a game.
Yeah, and I can like feel the pain of those guys that using the engines without hot reloading. Like I was like this myself, and when you spend like 2 minutes building the game, running to a specific point to test some stuff, and that testing actually takes like 5 seconds, and basically every iteration just takes 3 or more minutes. That's insane.
Yeah,
It's
I don't know how you get anything done in that world. Because you're trying to tweak like how high a character can jump by the time you get the next experiment.
Basically changing tiny small variable, and you need to restart the game. That's just like it could be solved by having a config files actually, but not everything could be placed in such files. So it's like hot reloading does allow you to change game logic in any way you like, but config files can't do this. They're just affecting data, and
yeah. You can change numbers with a config file, but you can't change like control flow. Yeah. Okay, so yes, I can see how I can begin to see how you get the very necessary feature of hot reloading for a game and still do it in Rust. Does that mean you are committed to Rust the whole way through?
No, not really, because recently there like a Lua was added for the engine, but it's a separate project, so it allows you to create scripts in Lua, and those, as far as I know, are also hot reloadable quite easily, and since this is those are interpreted languages, like, and it works much faster and much more reliable because you don't have to mess with the process memory and such low level things. And also there is some research, as far as I know, to add C# support. But that's in very, very early phase, and I don't know how it will like come out.
But this, in that case, lets me think about the various subsystems, because I know there's at least one part of I think it's the collision detection system which you haven't written. You've you've got a Rust library, bringing that in.
Yes,
So
exactly.
what are the interesting libraries, and what are the bits you've bitten off yourself?
I'm using the Rapier 3D and 2D for 2D physics, and it's very awesome library. It's very stable, and with recent updates, it's like super stable because in some earlier versions it had problems with joint stability. Like when you're creating a ragdoll, it like blows up, like some limb merging into another, and then like boom, explodes, and your
Yeah.
character like fly away.
Yeah, your character's arm falls into the other arm, and suddenly it looks like
Yeah.
an explosion waiting to happen.
And it like
Yeah.
sometimes stuck in objects and create those blood splatters like.
Yeah, I'm sure I've seen that in demos.
Yes, it's like a very common bug. And as for other parts of physics, yeah, but basically, yeah, I'm relying on the Rapier physics library, and it does all the heavy lifting. But previously, I had my own physics library, but this topic is like. It requires some very, very good knowledge of math, and like it's not enough to have basics of linear algebra to get into it. So I implemented some collision detection algorithms back in the day. It was GJK algorithm,
Okay.
like GJK algorithm for intersection detection of convex polygons, or no, convex objects, and then implemented the expanding polytope algorithm to get a penetration vector between two objects, like how much you need to like push objects away from each other to make them don't contact anymore.
Okay,
And
yeah.
but after that, it was time for like rigid body dynamics, and that's the part where I gave up because I realized that I need to do joint system then, and it involves some math that I don't understand. It's like Jacobians and other parts like from math that
Yeah.
like tensors, if I'm not mistaken, are also used there, and
Yeah.
it's
See, I can
super
imagine you
complex.
being very glad to outsource that particular part.
Yes, exactly.
But do you not face the same with rendering?
I know, because rendering is actually much easier for programmers because it doesn't.
Okay.
It uses math as well, and sometimes those like scary parts, like integrals and derivatives and stuff. But in reality, it's much simpler, and also there are like quite a lot of good learning materials throughout the internet, and like some advanced stuff like Google Filament that allows you to build your own physically based renderer, and it has like math and code together on the same page, and you're like, oh man, this like integral, what does it do? And then you see it, like,
Yeah.
oh right, it does this part, and it's much simpler. So and rendering itself, it's like not about math in general, but it's super complex itself because it requires you to do proper. Basically, it's about how well you prepare data for GPU. Like it's you
Oh,
need to
okay.
pack
Yeah.
data, send it to GPU, it start processing, then you need to like write shaders that does the math on the GPU, and sometimes the slow part is this preparation step where you need to prepare batches for GPU and send this. And this is an interesting task itself. Like it can be solved in many ways, like using a render graph and such other stuff. But I'm using like evolutionary approach. I'm not trained to like create a cutting edge approach right away. I'm like starting with something simple, adding more functionality, refactoring stuff, and like you need to split complex tasks into smaller ones, because otherwise you will just can't finish anything otherwise.
Yeah, yeah. I totally believe that. I'm just surprised that you managed to split all these small tasks, still be writing most of them, and write at least one game in this engine at the same time.
It's actually 3 games that I wrote, and there are quite a lot of projects that I know that using the engine, uh, and some of them are in like commercial projects. Uh,
Really?
yes, but like I had a conversation with the person who, like, here's the money for your work. I got some commercial task. And I did it with your engine. Like, this is your part of the money,
Oh, that's cool.
and they told me that they will like showcase their work in the Discord server, but it isn't there. I don't know why. Sometimes people, sometimes people come to Discord and like complain about some problems in the engine, and I see that they are working on something, but they for some reason don't want to share their work. I don't know
I,
why this happens. This is like beyond my imagination.
yeah,
Why
I
this happens.
imagine in the game release cycle, you kind of have a hype budget, right? You kind of don't want to say what you're working on until it's ready. But that's the first time I've heard of someone being reluctant to talk about the project, but still willing to send the open source developer money for it.
Yeah,
So that's quite nice.
yeah, that's cool.
Okay.
Yeah,
I am beginning to get something of the shape of this in my head, right? I see how the scripting system works, object hierarchy, message passing, rendering. You've just about convinced me that that's a tractable problem by a solo developer. Another huge part of this, and I think must be really important for building a proper game engine, is like the whole UI toolkit.
oh, yeah,
Tell me about
that's
that.
yes. Since I'm a tools programmer, and yeah, the UI is very hard task actually. And back in the day, I used WPF from Microsoft at my job,
Hmm.
and it was like this enterprise huge package that allows you to build interfaces with this markup language called XAML, and it is so had like has like tons of features, but you use like a tiny fraction of them. And yeah, I was so impressed by this library, so I basically created my own UI library inspired by this, by the WPF,
Hmm.
and it was a super hard task, really, because I never done anything like this before. I did some simple UIs like what do you need in games, like buttons, text, some sliders, maybe lists. And when you like trying to like do a generic approach with this, you immediately start to realize that it's like an iceberg. Like you see
Yeah,
a
yeah.
small top, and the
You
rest is
can
hidden under the water.
Yeah, you can see at least 20 years of arguing about UI frameworks in the JavaScript world, right?
Yeah, exactly.
Yeah.
This like never stops. And the UI system and the engine, it is inspired by WPF, but since it's written in Rust, it uses very specific like Rust approaches, because for example, the layout system, which is the core of any decent UI library, this system doesn't force you to like directly specify positions of like buttons, texts, and so on, some other widgets. Instead, you like tell in this widget will be at the right top of the parent widget, in which bounds it stays, and you can change the alignment of it for any corner, center, left, right, bottom, and so on. And some other stuff like direct positioning is also applicable in here. Like sometimes the sliders allow you to do constrained movement along a particular axis. And this layout system is probably the most hard part of any UI system, because it is complex, because it requires you to do two passes. First pass measures the widgets. The entire hierarchy is measured, so you know how much size each widget wants to take, and it starts to become complex when you have arrangements like grid, because in grids you have you can specify that your row will take the height of the largest object in it. Like it could have like 3 rows and 10 columns, and the height of the row will be the max height of every widget that occupies this row. And like some rows requires to be stretched, so they will fill the rest of the space available in parents bounds. There are a lot of these arrangement techniques, like lists. They are stack panels. Basically, a list is it's like a stack panel, like it stacks on next item above the previous, or it could stack them in horizontal way. And
I can definitely think of situations in like CSS where the child constrains the size of the parent, and the parent sometimes constrains the size of the child.
Yeah, exactly. And sometimes you need to measure twice, which could lead to this increasing complexity. Normally you would have like ON, like this asymptotical complexity, and when you measure twice, you could end up in like O and power of 2, and this it's quickly get out of hand and starts to eating performance like crazy.
I'm really surprised to hear you say that when we talk about 3D rendering, you say, oh, that's just casually linear algebra and integration. When you're at UI, suddenly you're worried about performance and algorithms. Is it genuinely that's the scarier part?
Yes, that's because I'm building the editor, and the editor is probably the most complex thing I ever worked on. Serious, because it has so much of moving parts. At the bottom layer, it uses the engine itself, so it is built using Fyrox itself. So
it is in one sense a Fyrox game.
Yes, it's sort of a game on the engine, and the next layer is those windows, the docking manager that allows you to hold windows in specific places on your screen, detach them, drag them, attach in different places, split place for 2 windows, attach them there, and we also need to build a lot of different tools. Like you need to how it is called, a world outliner or world viewer that allows you to see which objects you haven't seen and how they are related to each other. This object have these children objects, and they are.
Oh, you want to see like almost like a file system tree hierarchy browser.
The tree, and also this tree also needs to be implemented in the UI library. So imagine that which amount of widgets you need to have to build an editor. Currently, Fyrox have 45 widgets, or maybe more.
Yeah, yeah,
All of
yeah.
them I used, like, and sometimes you have very weird widget like a curve editor, and why would you
Oh, of
need this?
course. Yeah, yeah, yeah. You
And
need like Bezier spline
yeah, exactly.
user interface.
For
Oh
animations,
god,
you
yeah,
need
yeah.
to have an ability to say to tell the engine how the like parameter will change over time, and which transition it will use will be linear, cubic, or something specific. And so it's in any way you go, you will face specific like tasks that will take huge amount of time. Like I was creating an animation editor for 4 months, maybe, or 5 months, and still sometimes it requires some attention to it because there are bugs in it that only found when you like using it extensively, and um, that's part of the reason why I'm using why I'm building my own game using the engine and the editor, because this is the only reliable way to find at least most of the bugs.
Yeah,
If you use this the tool you're making, you will be familiar with this like quirks and other weird places, and you can fix them. And since you are using it, you built it, you can fix it quite fast. So you don't need to be like Unity. This is like insane. It's a very bad example actually, because they, um, as far as I know, they at some point made a game using Unity, and this game was built by their own department.
mm.
I can't remember the name, but recently they decided to like throw it away, and let the community test their engine. And sometimes it leads to bug reports that aren't closed for like decades. And
Yeah.
why do we need to care? Those guys will fix them by themselves. And
Yeah, yeah. I sometimes think one of the hardest things in industrial computing is like if you're writing an accounting package, as a software developer, there's a very, very small chance you'll ever want to be a user of it, right? And for
yeah, yeah.
a lot of industrial computing, that's even worse. I mean, when would I use an insurance accounting system?
Yes,
Right?
exactly. You need to like trust to the competence of those developers, and
Yeah, but they
pray
can't
that.
get that experience. Whereas if they're games developers, they stand a chance of like getting the experience of the engine you're making. Yeah.
Yeah, exactly. And this all of this is very very interesting, because you are creating a tool and you are the user of it, so it's your interest to build a reliable tool and helpful tool that will save time.
Yeah.
So pretty much any tool that that like humans made throughout the history were designed to save time. Like, why
Yeah.
would game engine not do this? If a game engine like spends most of your time on simple tasks, and why use a game engine?
I can
It's like
see why
getting
you
in
would
the
end up.
way.
I can see why you'd end up in a situation where where you're going to the effort of putting in hot reloading, because that only really starts to matter if you're feeling the pain of not having it,
Yeah,
right?
it was so painful because hot reloading is like maybe a year. Yes, it was implemented a year ago, maybe, or maybe even less. And before that, it was so painful. Like
Blue.
a Rust it can be compiled pretty fast. Like you can cut down to less than a second, but your game state will be lost, and you need to reiterate all over again to create those exact situation that goes
Yeah,
bug.
yeah, yeah.
And
It's not just recompiling the whole system; it's also running through the game to get to level
yeah,
3, right? Where the thing you wanted to test was.
exactly, and that
Yeah.
takes like enormous amount of time. Here's a small example from my previous work at Larian. They have this like their editor, and it was super slow to compile. Like a small change, and it will compile for 10 minutes, even on a beefy beefy machine, like with like 16 core CPU and so on.
Yeah.
And like you did some stuff, pressed compile, like wait for it to finish, and you return to it and forget what I was working on.
Yeah, I know I changed a number, but what did the number mean, and how
Yeah,
much did I
exactly.
change it by?
How to test my change? It's like this, and those iterations are super slow and so annoying. And
I remember there was an old PlayStation game that solved that problem by having Lisp as the business logic, and would just send list over the wire, which you, like you said with Lua, you can do that with an interpreted language. A compiled language, that sounds like it'd be much harder to get right.
Yeah, compiled language. Since this is native code, this basically leaves you alone with the CPU, and like if you do something wrong, it will just stop your application and tell the operating system to shut it down and go with this memory dump and try to debug it. Have fun.
Okay, I've got to ask then, how long did it take you to get the hot reloading system working reliably?
I tried to implement it even before, and before this, and it was like maybe 3 years ago, and that was a failure because I'm used the wrong approach. For some reason, somehow I got in the situation when the game and the engine used different versions of the code. So it's basically not the engine, the editor, and the game used different different engine versions. So basically, it was two libraries, and they are very incompatible, and because they weren't produced by the same from the same compilation procedure, and Rust generates some internal, for example, type IDs that simple numeric values that different across compilation attempts, and I couldn't solve this, and then like a year ago, I asked a friend to help with this, and he was experimenting with this hot reloading for quite a long time in his own Rust engine, and with him helping me, I managed to finally figure out those weird dependency issues where you have these wrong library versions and so on. And basically, it took me in some maybe a month or so, because it sometimes those example with vtable related crash, it was alone like a week trying to debug why it happens. Because
a month sounds fast, but as a second attempt with someone else who's crossed that path with you.
Exactly. We don't need to work alone if we can ask help.
Yeah. So let's lay it into that then, because you worked on this mostly alone for something like 4.5 years.
Yes,
right?
something like this. Yes, and there were some contributors that came along and added a huge chunks of code. Like reflection system was initially run. Yes, reflection system. Yeah. And serialization also was written by a single person from Japan. And
when you say reflection, you mean like runtime introspection, not light bouncing off the water?
Yes, exactly.
Yeah, okay, just checking.
Yes, exactly. Because I need the reflection system for the editor, so the editor can introspect objects, so I can edit them, and something like this. It does not allow you to do some crazy stuff like C# reflection system, say something like calling methods in the dynamic way. But it provides access to internals of a structure, and that's very, 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 very helpful to build in the editor.
Yeah, I can imagine.
Rust, unfortunately, does not have this built-in yet. As far as I know, there are some proposals for this. Maybe sometime it will be implemented, but whatever. We've just built our own system.
Go on, then give me some hints. I'm too curious not to ask. How do you retrofit reflection into Rust?
It's basically built on top of, not on top, using the procedural macros of Rust. It allows to execute some code written in Rust to modify the abstract syntax tree of your code, insert some functions, add implementations for traits. Basically, it's a code generation.
Generation of the compile time information you're going to need.
Yeah, exactly.
Yeah, okay, that makes sense.
And it is indeed restricted in some places, but it works for like 95% of time, and yeah, it's super helpful.
Yeah.
And serialization is also written using the procedural macros, this code generation, because it's basic, but it is much simpler than reflection, because reflection requires you to create a lot of methods that allow you to access various fields of structures and walk over them in would walk over a tree structure, and you need to fetch some information like name of a field, type of it, maybe some additional information like a description string for the editor. So the editor, you hover the mouse over some field and will give you a hint what it does. So yeah, it took to build a simple basic version of it. It took probably, I don't know, probably like 3 weeks maybe. But then it was extended, and it's still not done yet, because it sometimes requires some specific routines, like that's specific to the engine itself, like. Since the engine allows you to create prefabs, which is a small scene that contains an object and not a set of objects, basically a subgraph. And those objects could have their properties, and you can instantiate this prefab on some other scene, and when you change this prefab itself, the changes will automatically reflect on those instances. And this also works in a hierarchical way. So you can have a room, and this will be like a prefab that contains other prefabs, like this microphone and some chair or something like this. Right. And these objects can have their own objects, because everything built from much smaller parts. And for example, you have 10 rooms, 10 such rooms in your large level, and at some point in time you decide to change something in that room, and if you wouldn't have the system of property inheritance, you will be in huge trouble, because you need to manually change all those instances. But with this inheritance system, you just need to open that prefab, change something in it, and it will be reflected on all those instances. And here you go. It's super simple. Yet it took me 3 years to implement it correctly, because it sometimes still fails for some weird situations.
Weirdly, that's reminding me of prototypical inheritance in JavaScript.
I haven't used this.
There's sort of an archetypal parent object, which isn't really, that just contains properties that every child defers to.
Right. if I'm not mistaken, there's the similar concept in Lua called meta table.
Oh,
maybe.
yeah.
Yeah. So I'm familiar with, but and it also like hierarchical, right? So you can like extend this archetype and like create a derived version of it, and then again derived version from it, and change the space, and that will reflect in those derived how would you call archetypes, right?
This all adds up to you pushing Rust quite a long way from kind of its origin story.
Yeah.
Yeah.
But again, it's interesting, and I basically can do this all day.
Yeah. I mean, I suppose given how you can build all those kinds of languages out of C, there's no reason you couldn't build all kinds of interesting language features on top of a Rust core.
Yeah, right.
Yeah. But again, this makes me think, how do you, as a largely solo developer, manage to fit this in? I mean, if I hired a team of 100 programmers and you gave me 5 years, I couldn't guarantee it would work.
Yeah, just it's like this like anecdote maybe when a woman can't born nine women can't born a child in 1 month.
Yeah. Yeah.
And the same is with the engine. When you start, you like have small number of places where people can work on, because you basically don't have anything like. But when the engine starts getting bigger, you clearly see that you have sound, editor, graphics, UI, and other parts.
Yeah.
And probably best way to do this is like to start with small team, and then add people to maintain mostly ready parts.
Yeah.
So
You
then
can't build the UI engine when there's no rendering engine to render it with, so you can't parallelize it. Yeah.
Exactly.
So is this why, excuse me, is this why something like 4.5 years in, you're starting to farm out the work to other people? Or is that more a social thing that people are starting to give attention to the project?
It's the latter, and people just like starting to get interested in the engine and work on it on design parts. Some parts I haven't touched for like years, and somebody starts working on this, and I couldn't even realize that something is broken in there, because I haven't used that in a long time, and people like, this stuff needs to be rewritten, or it's like have these bugs and these bugs and so on. And that's cool when you have large engine, and like it allows you to get a high level of parallelism to like, it's like an ideal parallelism where each one do not interfere with each other.
So in that case, that raises the double-sided question of what state would you say Fyrox is currently in, and where do you want to get it to next?
It is currently able to create pretty much any kind of game, starting from simple 2D platformers and ending up maybe like relatively big open world games. It still don't have some features that needed for these kind of games, like world streaming and
World streaming.
Yes, exactly. It's where you have your world divided into chunks and do not load everything at once, but load sorry, and load that when you like traversing the world, like you've come closer to another chunk, it is get loaded, and the other one is unloaded. And because you don't have all memory in the world and processing powers, you like limited to some small amount of memory.
Yeah,
and you
this is the old thing, like in the Grand Theft Auto games, where to get to the next island, you'd have to cross a bridge that was suitably long and boring that the game could secretly unload one island and load in the next.
Yes, exactly.
Yeah.
It's exactly this. You need to be able to hide that part of world that you don't use.
Okay, that's world streaming.
Yes, cool. Exactly. And maybe if you have like tons of objects, the current approach with OP is not so good, because again, ECS is here not just because everyone like wants to use it for some reason. It's exactly for solving specific problems. It's another tool that that has its own uses. Like specific use is maybe high parallelism with large number of objects, like maybe a real-time strategy where you have like thousands, tens of thousands of enemies on map, and like maybe the good example will be like Total War game, maybe something like this.
War. I don't think I know that one.
It has huge armies. If I'm not mistaken, the title. It has a lots of moving parts on screen. Let's say it in this way, and you need to process everything at once, and you need to efficiently use CPU resources for this. So,
is this like the kind of games where you've got a battlefield simulation and there are tens of thousands of fighters, and you're trying to model each one individually rather than as a battalion?
Exactly. Imagine how many moving parts are there. It's crazy amount of moving parts, and so. But again, this could be solved by using ECS with the engine, and there's nothing wrong about it. You basically, people use ECS with Unity, Unreal Engine when needed, and get this crazy performance when needed. So again, use the right tool for the job, and it will be solved pretty easily.
So there may be some time in the future where ECS gets bundled into Fyrox.
It's maybe.
Or you just roll your own?
Maybe I don't know really, because I don't want to try to build everything in ECS, because it's like counterintuitive. Like building UI in ECS, it's like I don't even know how to do this, because it is so. It is different, like task. It's like in parallel dimensions.
Okay.
Because it's UI in naturally is like a hierarchical structure where you like using either callbacks to interact with like events from widgets, or maybe message passing that Fyrox uses, and it uses hierarchy to deliver events, or maybe callbacks, and so on and so forth. And I simply don't understand how would one build that in ECS. The guys are trying in Rust build everything in ECS, baby, and it's totally fine with this. I'm totally fine with this, but yeah, it's like super complex and counterintuitive, in my opinion. I don't want to start another flame war, like which engine is better, which not.
Well, let's say that a hierarchical UI is a well-trodden path that doesn't need too much research.
Yeah, exactly.
Yeah. Okay, so I'm now thinking of one other incredibly large part of this project, which I don't know if you're responsible for it directly, but there's a whole book on how to use Fyrox, right?
Yes, exactly. And I also made this.
You wrote the book as well?
Yes, exactly.
How many of you are there?
Guys, can you please like get in there? There are like an army of my clones right behind that door.
That's the secret. Just clone yourself.
Yes, exactly. And this is not my apartment. It's like a open space where a lot of people sitting in there. Mostly my clones.
How did you find time to write a book on top of this?
It's basically when somebody asks a question in Discord server, I go to the book and write an article there, and like here's the link. Just read it.
Okay.
And
Only answer questions once.
Yes, once and for all, I hope. And that's really good approach, because you don't need to answer that question over and over again, and at some point it starts to annoy you, and newcomers might consider you like a toxic person, and when you they don't know that you have answered this question like thousands of times already.
No, of course not.
Yeah.
So
And
you're actually seeing writing a book as a time saver.
it's a huge time saver. I don't need to answer those questions ever again. Those are in the book. And also there are like tutorials for the engine, and there is also documentation for specific parts of the engine, like what each node does, how update loop is working, which events are which for, and so on and so forth. And yeah, it's an iterative process as usual. You start from something simple, like how to build the engine, and then you start adding some useful information here and there, and eventually it gets bigger and bigger. As far as I know, I added Google Analytics to the book, and each day it is visited by a few thousand people.
Okay.
So it is. Imagine those people will go to Discord and start asking questions there. I will be probably not happy, to say the least.
So where are you going to go to in this? Like, if I were to phone you up 3 years from now, do you think Fyrox will be in some games, a lot of games? Will you still be building the engine, or will you be stopping and building your own games on top of it?
I hope it will be used in games, those that you can download from Steam and play. Currently, I'm building my own game that allows me to improve the engine, and I hope I will release it someday, because I need this, because I want also to switch to other game genre, because I'm kind of bored by third-person shooters that I'm currently building. It's like when you do this for like more than 3 years, it's like becoming like a job, and it is quite annoying. And also when the engine changes and you need to change a relatively large game, it's so annoying.
Yeah.
Imagine that Unity would change almost everything in every version. I don't think that developers would like this at all.
Yeah, you've only got one person to blame, though.
Yeah, so that's part of the reason why I'm trying to introduce as least breaking changes as possible, because I'm the user of the engine too, and I'm not interested to rebuild the game from scratch again and again, because I wouldn't create anything good from this. It would be a wasted time.
Yeah, totally. So if you're not busy out there selling games on Steam to support this, how is it supported?
It's like mostly donations from people. The engine is funded by donations, and those donations are this small, maybe.
Oh,
it's super
the life
small.
of an open source developer.
Yeah. Exactly. It's like at peak, it was like $300, maybe $400 per month, and it was like for a few months, and then it like dropped to 200, and now it is like $50.
Jeez, and still you keep going.
Yeah, that's because that's my passion. It's not about money. It's about solving interesting tasks, and like when you have something interesting, you can spend all day doing it, and nothing can distract you. Even maybe hunger will distract you, but
it's one of the few things. Basic bodily functions.
And I have some savings, so I like to work maybe 2 or 3 years, then take a break for a few years. That's how I'm working right now. Currently in this how would you call it, vacation state, maybe.
Yeah, what do they call it? A sabbatical.
Yes,
So you
exactly.
take the time off, but you're still working jolly hard.
Yeah, exactly.
Yeah.
And like I worked for almost 3 years at Larian Studios, helping them build Divinity Original Sin 2, Baldur's Gate 3, and then I have like a year, more than a year break, and then I was hired by PlayerX to create some mobile games, and then I worked there for like almost more than 2 years. I can't remember exactly, and that allowed me to build some like financial this like
A nest egg.
yeah.
A war chest. Let's give it a gaming
Yes.
term. A war chest. Yeah.
And so I can live without the fear that tomorrow I will like eat nothing or something like this. It's actually very good approach if you want to work on your own like project, but that's indeed not for everyone, because family it's quite a lot of money monthly, so you need to have huge pile of money to to support your
and
family.
living with the uncertainty isn't easy either.
Yeah, exactly. So you can't focus on your project while being like unemployed and with tiny amount of money. So you need to build like a stable foundation to
Okay,
do
then,
this.
speaking of stability, if we want to answer me these two questions, if we want to commit to the stability of Fyrox and support you, how does someone donate? And if someone wants to start writing a game, where do they start? What are those links?
About donations, there are like maybe there are three options basically. You can like either donate via Bitcoin, which is as acceptable for some people, and there's Patreon, there's local services of my country, and so you can do any you like. But I think the most valuable for me would be to see a game on the market. That's I think that's the dream for of most of open source developers. But sometimes it like gets a bit gets a bit annoying when you see your work, but you don't get any recognition from this, and like maybe my own dream would be like to have a developers, like a team of developers, like a few people maybe, who will work on the engine, not full time, because I'm myself not working on it full time. Basically, I'm working on it where I feel passion for it. But I'm trying to do something every day, so I want detach mentally from the project so much. And yes, something like this. Maybe some document. Maybe somebody could write some documentation. Maybe like contribute to the code itself. Maybe create some tools. Something like this. There are lots of ways. If you don't have money, you can invest some time in it, which is basically equivalent of money.
Or release a hit game and make sure people know that you wrote it with Fyrox, and maybe send a small royalty your way.
Yes, something like this. It's the engine will be free forever. I'm not like Unity, who did dirty things.
I heard a little of that controversy.
That was insane. Like this fee that they were trying to push.
Okay, so should I, if I put a link in the show notes, should I start with the book to learn how to use Fyrox?
Yeah, exactly. It has pretty solid like chapters for beginners. Like there's like how to install the engine, how to create a scene. There are tutorials like how to create a 2D platformer, how to create a first-person shooter. They're all not so finished. There are like in the platformer maybe 2 parts. In the first-person shooter, there are 3 parts covering various aspects, even the animations. And yeah, it's a good way to start. I'm also sometimes people ask me to do video tutorials, but I don't really like them because they will take. I can't update them easily because if the
Yeah.
engine changes, it's like very quickly becomes obsolete.
Yeah, and you can't be constantly refilming videos. It's
And
hard.
that would be insane. This is insane to rewrite the book when something changes, but hopefully Rust helps here too because it has an ability to test code snippets in the book using the any library you want. So you basically click a button and it tries to compile code snippets and tells you where's there. So you will have this up to date, and nobody will complain that here and there you have like messed up code.
Right.
And
So that's one of the things you need then, which is like a YouTuber constantly creating videos about Fyrox, who is
yeah,
delighted for an excuse to record a new video and re-release it.
yeah, exactly. And I did a poll someday, maybe even 2 times or maybe 3. Which kind of tutorial would you like to see? And most of the people, maybe 85%, was for the text plus images version, not the videos, because in a video I would like speak in this like broken English that I'm speaking right now, and it can be easily translated. But with today's tools like an AI assisted translation, it is feasible. But it's still not so great. So and textual versions can be easily scrolled to any point you like, and you can read it at your own speed, and it is much more comfortable than videos. So maybe at some point I will create a video tutorial when I feel that the engine is stable enough that this part won't change, at least for maybe a year or so.
Well, if you weren't busy enough already, there's another thing to get involved in.
Yeah, I have a lot of free time.
Yeah, sounds like it. Because of all your army of clones.
Yeah, exactly.
On which point, I'll probably leave you to go and feed the clones. So, exactly. Dmitry, thank you very much for joining me.
Thank you.
Thank you, Dmitry. As usual, I'll put links to the Fyrox homepage, the Fyrox book, and everything we discussed in the show notes. I'm also going to put a link to Pico 8 in the show notes. If you haven't heard of that one, that's a really interesting project. It's another game engine. It's also built by one person, but the way that they controlled the scope of that project was by saying this is just for making retro games for a virtual 80s style console. Very cool project, lots of fun to play with. I have tried and failed so far to get in touch with the author, but they remain on my wish list of guests. So if you know them and you know how to persuade them to be in a podcast, please do. I would hugely appreciate it. I would also hugely appreciate it if you took a moment to click like if you liked this episode, rate it if you're on one of the podcast apps, maybe share it with a friend, and make sure you're subscribed because 2025 now lies ahead of us, and we've got some great episodes coming down the line, so make sure you're subscribed and you won't miss them. In fact, on that note, I best go and record the next one. So, I've been your host, Chris Jenkins. This has been Developer Voices with Dmitry Stepanov. Thanks for listening.